Welcome to Unit 2, Lesson 2. The topic is utility maximization. We're going to take the concept of utility beyond one good, so where we deal a little bit more with a real-life scenario where we are choosing between different goods. And in real life, we're not just choosing how much of one good to consume based on how much utility it gives us. We're choosing whether we should consume more of one thing as opposed to something else. There's an opportunity cost for every choice of what we make to consume. There's costs that have to do with our with the money that we have to buy them, and then there's just some things that are just a matter of time that we have to give to them. But there's costs associated with everything, and there's many different options for us. So in real life, consumers go through the world maximizing utility based on comparisons among different types of goods. So here we're going to analyze how some of those decisions might happen using this concept of utility. And we're going to use that to come up with a couple of explanations for why the law of demand is the way that it is. Why demand slopes downward, which is a very obvious thing, it seems like, but with this concept we're going to be able to kind of more rigorously prove it. What you want to get out of this is three different things. One is the ability to solve these types of problems you'll see about what's the utility maximizing consumption bundle. That's what we'll do with these tables down here. Second, you want to be able to cite the utility maximization rule. So you need to understand this optimal consumption rule, which we'll get to. And then lastly, connect that with why the demand curve is the way that it is. So to introduce this, we'll talk a little bit about consumption choices. Like I said, in real life, we are choosing among different goods, and I pulled up a restaurant menu as I think a good illustration of that. There's Binkley's, which is a restaurant my family and I like to go to. It's close to our house. It's kind of a go-to, casual dining type place. And like your typical place like this, you've got a lot of different options for dinner. You could eat a burger and sandwich for dinner if you feel like that. You could have these pastas, seafood, steaks, chicken. You can get a personal pizza or pizza to split. And so when you're going into a restaurant and you're considering what to get from the menu, just think about what goes into that decision. First, obviously, is how much will any of these items give me in terms of utility, in terms of satisfaction or pleasure. So if we were just considering, if I was sitting down at the restaurant and I was just considering the utility that I would get from the goods, nothing else, I would just look at this and say, okay, which of these items would make me happiest? And I would just pick that. And looking at this off the top of my head, I guess right now I feel like grilled salmon. So that sounds like the one that would give me the most utility. But I'm not necessarily going to pick that. And the reason I'm not necessarily going to pick that is because of, hopefully you guessed it, the price. It's one of the highest priced items on the menu. And while it's not that much, it's not an expensive restaurant, we're not talking about a huge amount. Still, when I look at that compared to, say, the pizzas, which I also really like there, which are $6 less, or to the pastas, which are a little bit less, you get the point. I'm considering at this point both the utility that the good will give me plus the cost of it, the price of it. Assuming I can afford it all, assuming that they're all within my income limit, I'm probably making some sort of comparison between, okay, how much more do I want the grilled salmon compared to, say, the breaded cod? Do I want it $6 more? That price makes some sort of difference to me. And the way we're going to work with that with the utility concept is by saying that with the marginal choice, the next thing that you consume, your marginal consumption choice is all about which good gives you the greatest marginal utility per dollar. We call that MU over P. The good that gives you the greatest marginal utility per dollar, and as long as it fits into your budget, is going to be the one you're going to choose next. So back to the menu, I would look at, okay, on a given night, I think that the barbecue chicken pizza, it's a little bit cheaper than the grilled salmon. I'm gonna like it almost as much. I would probably go with that one. That's the way a rational consumer, we would say, would make that decision. Not that people always do, of course. There's various things that might be irrational, like maybe you're trying to impress your date, so you want to order a more expensive thing, or maybe you're like my dad, who likes to order the least expensive thing just so he can get the best deal. Those are all real behaviors, but they're not what economists would call the most rational decision, depending on how it could be. Anyway, the MU over P rule is what we're going to use to solve these problems where you're given a couple different goods. And so you're asked, what is the optimal utility maximizing consumption bundle, meaning combination of these two goods, which meets your budget limit? So assume with all these problems that you want to fill out your budget by as much as you can, given your income constraint. And so we're given here $20. Say we're going to spend $20, and this is the one given from the book. Here, back to clams again. Clams and potatoes. What's the mix of clams and potatoes that this consumer should buy, given that clams cost $4 a pound, potatoes cost $2 a pound, and here it gives us the utility that this person gets from clams and the utility that they get from potatoes. So the first thing we're going to do is to find this value for each consumption choice, each marginal choice, which means each additional amount of clams and each additional amount of potatoes. So I'm going to put two more columns here. I'm going to put marginal utility and then marginal utility over price for clams. And same for potatoes, marginal utility and marginal utility per dollar. So we know how to find the marginal utilities. We've got total utilities here. We know the first clam gives us 15 utils. And we just look for the change from one to the next. Next clam, gives us 10 utils, 6, 3, and 2. Do the same for potatoes. First potato gives us 9.9. Sorry, second potato. First potato gives us 11.5. Next, 9.9, 8.4, 7, 5.7, 4.5, 3.5, 2.7, 2, and 1.5. Okay, now to get the marginal utilities per dollar, we're just going to divide those marginal utility values by the price of the good. So the first one is 15. Clams cost $4 a pound, so 15 divided by 4, it's going to be 3.75. 10 divided by 4, 2.5. 6 divided by 4, 1.5. 3 divided by 4, 0.75. 2 divided by 4 is 0.5. There's our marginal utilities per dollar for each of these additional units of clams. And for potatoes, our marginal utilities per dollar, got 11.5. Now the price of potatoes is just $2 a pound, so just divide each of these by 2. We get 5.75. We get 4.85, 4.2, 3.5, 2.85, 2.25, 1.75, 1.35, 1, and 0.75. Okay, so now we have the marginal utility per dollar of each clam as we go and each potato as we go. So let's consider we have a choice with our first purchase to buy either a pound of clams or a pound of potatoes. Basically, we're just then going to compare, okay, do we buy this first pound of clams, which gives us 3.75, or do we buy this first pound of potatoes, which gives us 5.75 utils per dollar? So we're going to buy this one. Check that one off. So we bought one potato, and I'm going to keep track over to the right of how much I've spent. So I've bought one potato, I've spent $2, and my total that I've spent is $2. So call this one on the left our purchase, the cost of that purchase, and a total of $2. Okay, now I'm comparing, do I buy the second pound of potatoes for 4.85, or do I buy, I'm still on the first pound of clams. This is the trickiest part of this. Don't go on to the second pound of clams yet because you haven't bought the first pound of clams. First pound of clams gives me 3.75. Still, the potatoes are better, so buy another potato. So I'm going to say that's the second potato. Cost $2. Total we've spent is $4. We're going to keep going until the marginal utility per dollar of potatoes falls below, for the next one, falls below that of the first clam, which now we've done. So for our fourth purchase, we're going to choose to buy a pound of clams. So one clam, the first clam, that costs $4, and the total we've spent now is $10. Now we're comparing next clam 2.5 with the next potato at 3.5. So we should do the next potato, 3.5. So that's 4 potatoes. Cost $2, total $12. Now we're comparing, we find 1, 2, 3, 4. Let's sum up here. There we go. Alright, we're comparing the next potato, 2.85, with the next clam, 2.5. So another potato, 5 potatoes. That off. Now we're comparing 2.25 and 2.5. Check out 2.5. Buy another clam. That's 2 clams. Cost $4. Spend $18. And lastly, well, we only have $2 left. Notice we've spent $18, so we definitely we can't afford any more clams. So we're going to buy this last potato. So that's 6 potatoes. Cost $2. We spent $20, our total. So in sum, we have bought 2 clams and 6 potatoes. And that's the answer. So here's one great thing about that. One is that if you were to go through and figure out every different possible combination of clams and potatoes that would fit into your $20 budget, you could total up, given the data we have here, just the utility from every different possible combination. And what you would find is that the biggest total utility you could get is this right here, 2 clams and 6 potatoes. There would be no other combination of clams and potatoes that would give you a better total utility than that. This method guarantees that you get the utility maximizing combination. The other thing is that we can use this to illustrate the rule for the utility maximizing bundle. We're going to look at, notice it wasn't a coincidence that where we ended up had a very similar marginal utility per dollar. Not exactly the same, sometimes it will be, but not always. Any other consumption bundle that would fit our income constraint of $20 would give us a larger difference in marginal utility per dollar than this consumption bundle does. And that's another reason why this is the best one. It's always the best one if it is the closest in terms of the MU over P's, again, that uses up all of your income. And again, if you went through and found all the different consumption bundles that uses all your income, these two would have the closest marginal utility per dollar of the last unit bought. 2.5 and 2.25 is as close as we can get in this given data. So there's our answer. We're going to do a number of these for practice because people tend to have some trouble with this concept. It does come up on the AP test, and well, I'll give you lots of practice with it in class. But once you get the hang of it, I think it's pretty easy at that point. Okay, so I already kind of previewed what you're going to see here on this slide. I said, the second unit of clams is 2.50 marginal utility per dollar, and the sixth is 2.25, and that's as close as we can get within our budget. And that is, here's the way the rule is stated: the marginal utility per dollar of good A is equal to the marginal utility per dollar of good B. If you have trouble kind of telling what that says, it basically looks like this: MU over P is equal to MU over P. MU over P of good A is equal to MU over P of good B. It says equal, that's the rule, but technically it's as close as you can get to each other within your consumption choices. That is a rule to remember, because again, that's one of those things that comes up on the AP test. It's if you have, it's going to ask, to maximize the utility from a consumption choice, from a bundle of goods, you want to do what? What's the rule? They want to know that you know that rule. It's a pretty easy one to memorize, but it is one that we need to. So that also takes us to the last thing we want to talk about, which is how this relates to the demand curve. The demand curve comes to us from the law of demand, which simply says that there is an inverse relationship between price and quantity demanded. Inverse relation between the price of the good and the quantity demanded. And of course, the demand curve shows that. As the price goes up, quantity demanded goes down, and vice versa. That's very obvious, but we could also prove that using this optimal consumption rule in a couple of different ways. There's two different kind of forces we could point to that are making this law of demand happen. One is called the substitution effect. Say that the price of good A, price of clams, goes up. What that does to the marginal utility per dollar of clams, the price is going up, the denominator is going up, then the marginal utility per dollar of clams is now falling. That means it's no longer, if you take us back to our optimal consumption rule, it's no longer going to be meeting that optimal consumption rule if now our marginal utility per dollar for clams is falling further away from the marginal utility per dollar of potatoes. And what that means is a rational consumer should start buying less clams and more potatoes to equalize the marginal utility per dollar. So all we've done here is say if the price of clams goes up, then the ultimate effect is that the quantity demanded of clams goes down, because the consumer is going to buy less clams and substitute them for other things to meet this optimal consumption rule. That is the substitution effect. And then second, we have the income effect. And for this, we don't even have to deal with the optimal consumption rule in terms of both goods. We just say, okay, if the marginal utility per dollar of clams is how we're choosing clams, we can still kind of go all the way through those options, but we're going to have to stop earlier. The marginal utility per dollar is with a higher price is going to be going down, and also we're going to be able to afford less given our income constraints. Even if we have the same income, we're going to be able to buy less clams. So then our quantity demanded of clams falls. So once again, we've gone from an increase in the price of clams, we can afford to buy less clams, therefore the quantity demanded of clams falls. And that is the income effect. So what's happening in a given demand curve is that you have both the substitution effect and the income effect happening typically at the same time. If you're given enough data, you can actually measure them out, but we're not going to get that complex about it. We're just going to say that as the price of clams increases, then the quantity demanded of clams decreases as a result of both the substitution effect and the income effect, that both of those things are going on to create this relationship between the price of clams and the quantity of clams demanded. Okay, we'll stop there. See you in class.